Hey guys, welcome to Great Learning. I think it goes unsaid that most of the times we want to watch a new movie, we usually start out by reading reviews and checking out the ratings on IMDb, right? Have you ever wondered if you could create your own system that would provide insights similar to the top movie lists on IMDb? Well, Python provides us with a plethora of tools and techniques that will help us achieve just this goal. Now, to find out how easy it is to do this on your own, make sure to watch along till the end as we have many interesting bits and pieces about the world of movies and of course a novel method of analysis that you might not know about. And I can tell you one thing for sure, at the end of this tutorial, I promise you that you'll be many steps closer to creating your own movie recommendation system. I know this sounds super exciting, right? So what are we waiting for? Roll that intro.
Before we get started, I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, coming to the agenda of this particular session, building your own movie recommendation system using Python, we're going to start the session out by taking an introduction and understanding what recommendation systems even are, right? We have recommendation systems everywhere in today's world, but we need to really understand what is the purpose of it. What is that system? Why is it required? How is it helping us? Is it making an impact? Are there multiple types of this, right? So we're going to check out everything that you might have to know about recommendation systems in a simple yet elegant manner. While we do that, I'm sure your curiosity will be very much building throughout the session of how you guys should build your own or how you guys should go about, building your own recommendation system as well, right? So we're going to discuss all the theoretical stuff which is required, everything from the details of the data set, what is our goal, what we should do, how we should do it, and giving you a practical demonstration of everything that we have discussed theoretically as well, right? So everything from the introduction to the topic to covering a good amount of theory that's more than sufficient to start your own recommendation system, and of course going to the end where we will be discussing a fantastic demo. It's a very simple demo. You'll see for yourself that at the end of this session, you can create your own recommendation system and it will stand right up to what IMDb does. Of course, ours is a very simpler version compared to what IMDb does. That's an extremely complex system, but at the end of the day, you will be extremely surprised at the result that we will get when we go on to do this, right? We'll talk about more when we get started. Perfect. Now guys, without further ado, let's get started with the first item on the agenda, which is introduction to recommendation systems, right? Now, ladies and gentlemen, whenever you usually think about recommendation systems, right, as a learner, as a person who's, coming from a Python background, coming from a data science background, or something similar, you really should think about this. Recommendation systems is really, I would put it somewhere around the top 5, applications or top 5 results of what we could attain when, you're using data science, right? So if I have to talk about a really popular application of data science, recommendation systems are definitely on that list whenever I talk about that. But why is that the case, right? See, recommendation systems are superb helpers that we have today, which will, help us with user experience, help us with products, help us with services. It helps us with so many things. And as and when we go on to discuss, you yourself will realize that, hey, we have been using recommendation systems all of our, all our lives, right? First of all, what a recommendation system does is it tries to predict the user's interest and recommends something to them. Now, I'll give you a very simple example. I'm just going to take maybe my niece. I have a 3-year-old niece. She's very cute. I'm going to take her to, let's say, an ice cream store, right? Of course, after the pandemic, or let's consider a hypothetical situation. There, 3-year-old definitely hasn't tried a lot of the ice cream flavors, right? So, how would she know? How would the little kid know what ice cream flavor to try, right? So then I usually, I've seen the kid for 3 years now. I can sort of guess what flavor the kid might like. So what I do is I try to recommend something, right? I say, hey, why don't you start off with something classic, something like chocolate, something like vanilla, right? So I am recommending something to the person there. Similarly, if this were, an iteration with a computer, what the computer is sitting at the other end and doing is my task for, as what I did for my niece, right? It is just sitting and recommending something, which, automatically wouldn't have been done, right? For example, if I go to Amazon and if I, let's just say I need a cap, right? Maybe I'm going on a vacation. Again, don't go on vacations unless the pandemic is over, right? So let's just say I'm going on a vacation. I have a cap on. I bought a cap from Amazon. Now, what happens as soon as I buy the cap is, if it realizes that, this is, of course, it's for an outdoor use. So it'll also recommend sunglasses or something like, sunscreen or something like that, right? Because Amazon knows, that, hey, we are trying to recommend these. The person might also need this. So it tries to predict, right? Another simple recommendation system that everyone has used, I promise, is when you go to Google, right? When you go to Google and you start typing something, even before you complete your sentence, you get 10 or 12 options, and this happens regardless of what you type, right? I mean, of course, there are certain terms which are not permitted to be searched on the Google engine, where it will not give you recommendations, but for 99.9% of all the search results, right? When you're trying to search for something that's, legal, that when you're trying to search for something that's popular, that's existent on the social media or on the entire world of the internet, you will find it, and Google will be intelligent enough to try to sort of trace your thoughts and give you a recommendation based on that, right? Now, I really don't remember the last time I actually typed an entire search string on Google and I hit enter, right? No, I just type a little bit of it, Google does the remaining bit for me, and I hit enter, right? We don't realize that it takes a ton of power, a ton of computing resources to actually give that amount of convenience to you, right? You really should think about that. These systems, basically what they try to do is they try to track the preference of a user, and they try to see if this user is trying to buy niche stuff on a platform maybe like Amazon. Now, I, consider myself as a gamer, right? So if I'm on Amazon, if I'm searching for a lot of gaming related stuff, maybe a new joystick, maybe headphones, something like that, what Amazon will do is it'll start recommending me, a lot of gaming products just because of the fact that I might have searched once or twice, right? That's the recommendation system in use. And I'm just giving you one example. If you actually put some thought into it, if you actually think about it, every single company out there who are trying to sell a product to a customer, or who are trying to analyze the result of a service, definitely is using a recommendation system in one way or another, right? It might be something as complex as Amazon recommending me something, but it can also be something really as simple as hey, you're doing this particular operation in Python or something like that. Do you want some help? Where the Python IDE will automatically fill up what you were about to type. Have you ever been in that situation where you're typing the code in Python or any other programming language, and the IDE, the integrated development environment, will try to predict what you're typing, and it'll automatically just put it out there for you. So you're manually typing and sitting in front of the keyboard and wasting your efficiency and time is no more there. Again, that's a fantastic, simple system, but then it has a profound impact on how we work, right? Perfect. Now, when you're thinking about a lot of these popularity, when you're thinking about how recommendation systems even came into the picture, I think it was super popularized by three giants we have in today's world. First of all, we have Amazon, right? I am sure you all have heard of Amazon. It's one of the world's biggest e-commerce chain that we have out there right now. And these guys, of course, everyone has shopped on Amazon, I presume. But whenever you've taken a look very closely when you actually shop, right? Maybe you just bought a couple couple of books, you just bought a couple of empty notebooks, or you bought a diary or something like that, right? A journal perhaps. Now, when you have a journal or when you have a diary, what Amazon also recommends is maybe it'll tell you, hey, why don't you buy a pen, or maybe why don't you buy a post-it or a sticky note or something like that, right? It knows that you might require that as well, considering that you've just bought this notebook, right? It is not trying to just randomly predict saying, hey, this person might buy. That's one thing. The second thing is it would have tracked customer behavior, right? Now, Amazon has made sales of billions and billions of dollars out there right now. So they have a ton of data, literally a ton of data, where they can use to assess and analyze what the users want. So if some other user bought the notebook, what is the next thing that that he or she did? Maybe in the same order, in the next order, or maybe let's just say 15 days from the particular person when he or she ordered, right? So they'll trace it, they'll understand, they'll have that particular data and say, hey, of course, if someone's buying a notebook, there's a good chance they might need a pen. So let's just give them a really good deal on a pen that they might buy. Again, as soon as you see it, you'll be like, hey, okay, I require pens, right? So let me buy it. It's not very expensive. What you just did is, the revenue that Amazon made, you just sort of increased it by a good number, right? I mean, they were selling a book, they were making a profit. Good enough. Now, if they also sold you a pair of, let's just say, maybe a set of pens or whatever it is, any sort of stationery, and again, they made more money. But it isn't like that's a bad thing. That's a pretty good thing, because you might have searched for it, you might require it, or let's just say the convenience is unbeaten here, right? Similarly, think about YouTube, right? Now, whenever you guys have been watching a lot of stuff on YouTube, we usually log into our Gmail accounts and we have YouTube on, right? So it tracks your data. It saves a lot of the things that you might have seen. So it basically recommends you stuff regarding a lot of the things that you watched previously, the same genres, the same type of content, and all of that, right? Now, if I'm a person, let's just say I'm just trying to learn Japanese, okay? Japanese is the language that I'm trying to learn or something like that. Let's consider a hypothetical situation. Now, what YouTube will do when I start searching for this is, most of the time it'll just keep giving me Japanese tutorials. But would it make sense if I were learning Japanese and YouTube is just recommending me maybe German or maybe some other language? No, I would not want to click on that, right? Why? Because that's not what I'm looking for. That's a bad recommendation system, or that's a recommendation system which is not optimized. A good recommendation system will pretty much give me everything that I was just about to search for and more. YouTube does this a lot, right? If you've been watching a lot of our education related content here, I am sure that you will have a lot more recommendations from Great Learning, because it understands that you absolutely love watching our videos. The second thing is, it knows that you get a good amount of content from our videos, and it's not just any content, guys. It's the highest quality of learning material that we provide for all of you all, right? So YouTube is intelligent enough to actually understand that this is very good quality content. People are interested in it. In fact, a lot of you all are very much interested into it. So we'll start recommending it to all of you all. Pretty simple, right? That's YouTube. And if we are thinking about Facebook, Facebook is fantastic, right? I mean, it went from being non-existent in the country all those years ago when we had Orkut, all the way to being really the world's biggest social media, the world's number one social media, as people would call it, right? Now, what Facebook also does, it starts recommending you people, it starts recommending you pages. Now, I am a guitar player. I play a lot of guitar. So I am in most of these guitar groups on Facebook and all of that, right? So even when I'm not doing anything related to guitar on Facebook, it'll either show me advertisements related to guitars, or it'll recommend me pages or groups that it'll say, hey, since you play guitar, why don't you join these groups? Or you might be interested to check this page out, right? That is the exact thing that Facebook says, that I remember. And it'll also recommend people to you. So for example, this might come as a surprise to you, but then this is the reason of why it happens. I'll tell you. The situation is, maybe you just joined a new office or anything like that, right? You just switched your office, or maybe you just graduated out of college and you just made some new friends. Maybe you guys just shared your numbers, but you never exchanged social media handles. But you'll be very surprised to know that maybe, I don't know the duration, maybe half an hour, maybe 1 day, maybe 2 days later, as soon as you open up your Facebook would be neatly recommending that same person to you, saying, hey, do you want to add this person as your friend? Now, how it works in the back end, that is definitely proprietary to Facebook, and apart from a little bit of detail, we really don't get how how the entire process works, because again, it's a trade secret. It is a fantastically efficient product. So when it's being done like that, it just adds a ton of convenience to us. Right now, I have met fantastic people, and I've joined a ton of groups, liked a couple of pages, just because of the fact that Facebook recommended it to me, right? And I just wanted to find out the reasoning of why it thought that I would make some use to it, right? So I was trying to reverse analyze and sort of re-engineer what Facebook might have thought when it was recommending this to me. So that is one of the reasons why I like messing around stuff with stuff like this. Just taking another different approach to see if you can find some new insights. So when I try to have these sessions for all of you all, where we're trying to teach you something, all of these things which will take a lot of time, right? So it's weeks and weeks worth of research. So we're going to make sure that you get the best quality of content, and we do it just because of the fact that even we sit and do a ton of research on this, right? Perfect. Now let's move on. The next thing you really have to understand, one thing about a recommendation system which really goes unsaid every time we have a discussion about this, is Netflix. Netflix, now it is super popular. Everyone has Netflix. I'm very sure that a majority of you all watching this particular video know about Netflix. Either you have a subscription, or of course, just like all of us, you're sharing a screen from your friend's subscription, right? Okay, perfect. Now, when this is the case, did you know that Netflix uses the world's most advanced recommendation system, at least in the commercial grade, as of what I know, right? So way back in 2009, when they were trying to become popular, they actually offered $1 million. Now, back in 2009, $1 million is a lot of money for Netflix, right? So they offered $1 million to developers who were willing to develop a very good recommendation system for them. Now, needless to say, it was actually a fantastic project. I don't know if they went through or not, but the recommendation system that Netflix has right now is so intelligent, right? When you think about it, it can go to such levels of depth to analyze what it is that you like to see, and to show you that you will not believe it, right? Now, I can go on and tell you about how Netflix uses this to a good extent, but I definitely suggest, maybe after watching this video, you guys should Google this, or maybe watch a couple of videos on how Netflix uses recommendation systems. It is absolutely fantastic. The artificial intelligence systems, the algorithms, the machine learning models that are sitting there that perform all of these duties to just show you one movie that you want to click and watch on, or a TV show that you have to click and watch on, it takes a lot of processing power, a ton of programming, and it just adds so much convenience, right? Why do you think Netflix is popular? Why do you think people find it fun to binge watch TV shows and binge watch movies? Or why do you think that people want to spend more time on Netflix, right? It is because Netflix is welcoming in a way where it starts recommending stuff which is, it almost feels like it's uniquely made for you, right? The entire Netflix company is just built for you. It kind of gives you that vibe, and that is the reason why, they're worth billions today, right? Similarly, a lot of people are doing this. We just spoke about Amazon, Facebook, Netflix, and a couple of these guys, but you really have to understand that when anyone wants to sell a product, there is a very good chance that it's not just one product that they'll sell in their entire life, right? So they might have something else. So they'll use the marketing, they'll use everything that went across with the first product and try to recommend another product based on that, right? That way you have feedback, that way customers can trust you, that way you can have items selling really quickly, and the benefits, again, we can go on and discuss about this, right? It's a lot. So at this moment of time, your takeaway as a learner should be that with recommendation systems, right, there is really no end to how much of an effect it can have on user experience, because every time a company comes up with something like this, and you as a person, as a data scientist, realize that, hey, this is a recommendation system here, I usually sit and, monkey around, try to find to what extent or how good it is, right? And of course, coming to Netflix, I really don't think that any other streaming platform, I mean, no offense really to any of the others, every platform out there is equally amazing on its own. But my personal opinion is that when it comes to recommendation systems, there is absolutely no beating Netflix, right? But then when we are throwing the term around a lot, right? Recommendation systems. Are there any types of recommendation systems? Are they simple? Are they complex? Are they, are there 10 types? Are there 15 types? I know you have this question. So without further ado, let me just answer the question for you guys. There are two very important types of recommendation systems that we have today, right? It's a simple recommendation system and a content-based recommendation system. With a simple recommendation system, this is basically how the entire concept of, let's just say, you trying to get a suggestion, maybe regarding a movie, maybe regarding a song, maybe regarding a genre of music or something like that, right? If you've been listening a lot to rock music, and if YouTube starts recommending you rock music, it's most probably using the type of a simple recommender, right? But then when you think about it, what are content based recommenders then? If simple recommenders are literally doing movies, they're doing music, they're doing everything. Content-based recommenders, right? Unlike simple recommenders, content-based recommenders understand what content is being shown. There is something called metadata. Metadata basically describes the data, describes the video, describes the movie, right? So in a content-based recommender, what happens is that the recommendation system understands what is being shown, what is being spoken, what is being, basically everything that it needs to know about the content itself. So using the insights, features, and labels and a lot of other things regarding that movie or whatever, it can recommend something else to you based on that. I'll give you one example. For example, let's just say that I'm a huge fan of Tom Cruise, right? Tom Cruise, the actor. Now, if I keep watching Tom Cruise movies on Netflix, or if I just watch one or two, what it's going to do is it's going to start knowing that, hey, this person likes Tom Cruise a lot, so let me just recommend all the nice Tom Cruise movies to this person. That is a content-based recommendation system, right? So if you just heard what I said, Netflix really uses both these simple type of recommenders, and of course you have content-based recommenders as well. A simple recommender is basically trying to use one or two features in a simple way to give you a product, right? You just bought a book. It'll just think that, hey, if the person bought a book, he or she might need a pencil as well, right? So it's going to be like, hey, do you want to buy a pen or a pencil along with this? Because popularly people have, you would have seen this on Amazon. People who bought this also bought this, right? People who bought XYZ also bought ABC. That is something that you definitely would have seen. And that is the thing. It's a mix of simple and content based that all of these guys use. But what we will actually be doing right now is, in fact, we'll be building a simple recommendation system, right? Having a content based recommendation system can get really complex to begin with for you guys to learn. But that doesn't mean a simple recommendation system is simple, right? We will have multiple features that we're going to be using to perform analysis. And you'll be very, very, very surprised looking at the results, as I just mentioned, right? Perfect. So I hope we are clear with all the types of recommendation systems that we have in discussion right now. So without further ado, I think it's high time we jump right into this and understand the approach in the theoretical way, looking at the data set and even doing it practically, right? So without further ado, let's actually get started on this. First of all, we need to understand what it is that we are trying to achieve, right? Whenever you're doing any sort of projects, whenever you're doing any sort of use cases, or whenever you're trying to, solve any problem at hand, always try to think of the problem, a lot. This is what we call as a problem statement. So our problem statement right now is for us to build a movie recommendation system that is very similar to the working of IMDb, which again is a very popular and a very famous website where you can get a lot of details about movies, reviews, rating, cast, and a ton of information about movies, right? So we have to build our own system which is similar to that. But what are we trying to recommend here, right? So what we're trying to recommend is, if you've ever come across these IMDb lists, right? Top 10 movies of all time, top 200 movies of all time, top 500 movies of all time, right? You might have seen that list. Now what we are going to do is, in fact, we're going to try to replicate the top IMDb top 250 movies, and we're trying to clone it, and we're trying to build something which is very similar to that using all of the metadata that we actually collect from IMDb. Now we have a data set where we have all the data from the movies present, right? We're going to discuss about that. So basically our problem here is telling us that, hey, you already know that IMDb exists. There's a ton of people who put out reviews there. Can you have a recommendation system by tracking one or two metrics of the data that the movie gives you, maybe like cast, maybe like genre, maybe again the rating of the people, a lot of different things. So can you use something like that and build a system of your own? The answer, what do you think, right? It's going to be absolutely yes. We're going to build this now. So before we actually go on to think about it, as I just told you, right, having the problem statement is really, really important. Understand what the problem is, because if you're trying to solve a problem that you do not know, it is very difficult. The second thing is, once you understand the problem statement, instead of directly attacking it, have a plan of action, right? Now, this slide actually shows you the plan of action that we are going to take to solve it, right? The heart of the logic, let's just say. After this, you're going to have to take a look at the components of what the recommendation systems are using, right? So, in our case, when you're trying to recommend something, you require data to even give a chance to recommend something, right? So we'll have to take a look at the data set as well. Now, we'll go to the data set aspect of it in a minute, but for now, what we're trying to do here is, this is how we will solve the problem of how we will create our own top 250 IMDb clone, right? First of all, we need to find a metric on which we can rate the movies, right? A fantastic thing that IMDb does is IMDb has its own rating system between 0 and 10, right? You can rate a movie, I think at 0.5 intervals, right? A movie can be, but then when the average weighted rating is taken, it is usually 4.8, 5.5, 9.8 and all of that, right? On a scale of 1 to 10, 1 being really bad and 10 being absolutely fantastic is how the metrics work. So let's see what metric we can find to do something like this, right? When we are practically checking out, you will have clarity on this. The second thing that we'll have to do is we're going to calculate this metric not just for one movie, but we'll have to calculate this metric for all the movies that we have in the list. Now, the data that we're using, you will find how many stars, what is the average rating that the movie has, and not just that, it gives you the number of people who have also rated it, right? It just doesn't say, hey, this movie is IMDb 8.2. No, it just says that, hey, this movie is rated at 8.2 on a scale of 1 to 10, and maybe 45,000 people have given their ratings. You can actually see the rating based on the age group, based on the country. You can even sit and analyze on their own website itself, right? That's how complex it is. Now, our thing is to make sure we simplify it, yet have a working logic that replicates that, right? Now, after we have a metric and it says that, hey, this is like a rating score for all of your movies that your own recommendation system is giving you, what is the next logical thing to do if you're building a top 10 movie list, right? You definitely have to arrange it in the descending order, right? The rating, the number between 1 to 10, that if that is the maximum, it means that is number 1. It gets higher preference, higher priority, right? Common sense. So what we try to do is we try to very simply arrange everything in a descending order. That way, the products of the highest rating will be at the first, the movies of the lowest rating, movies, products, anything, right? So it'll be whichever has the lowest rating will be at the last rather than the first. This is a very simple arrangement, but then these are some of the steps that we are going to take to solve this problem. Correct? Okay. Now, what we can do next is actually take a little look at the data set, because having an understanding of the data set is everything, right? It has a huge impact in having just a good solution to your problem versus having a great solution to your problem. Now, what is our data set in consideration here? First of all, whenever we're looking at the data set, our data set is again a super popular data set. It's available for free, all over the internet. It's called as the movie lens data set. What it contains of is it's somewhere around 45,000 movies, right? There is no language barrier. It contains movies from multiple different languages, and it just has all the metadata of 45,000 movies. Now, if you're curious about what metadata is, I'm going to show this practically. It's basically like who the cast members are, who's the hero, who's the producer, who's the director, where this movie was shot, what was the budget of the movie, how much profit have they made, what is the rating score, how many people have rated, are there any comments. There is a ton of things you can do on IMDb, right? So basically, this data set just takes a lot of that and just gives it to you in a very structured format that you can use, right? So as I told you, name of the data set is movie lens. The number of movies or the details present in the data set is 45,000, which is again more than enough for our case, and it consists of all the movies that have been released up until the year 2017, specifically until July 2017. Now, you definitely can have another dataset or multiple datasets such as this, where maybe you just want to find out everything until what happened yesterday, right? So if you want a dataset, I definitely think it's available. February 2020, March 2021. You find all of these datasets which has details about about movies contained in that. So for our case, we have everything up until July 2017, and once you see the result, this will not matter a lot. I'll tell you why, right, when we are discussing about the movies. So I just told you about these features that we're going to use to build our own recommendation system, right? So what are these features that we are talking about that's present in the data set that might be of use to us, and how we will use it to the best of our abilities? The first thing is cast and crew, right? Cast talks about all the actors, of course, and then you have the crew, as in the camera crew, the director, the producer, as I just mentioned. All of those people are features as well. As I told you, how does Netflix recommend something to me from a movie where Tom Cruise has starred, right? It's because it knows that I am watching a movie where Tom Cruise is starring in, and then it'll also recommend the same thing to me. So it knows about Tom Cruise. Again, this is a feature that Netflix at that second used to analyze and recommend it to me. And then we have plot keywords, right? Plot keywords are again working super fantastic on Netflix. If you've ever been this person who likes watching documentaries on Netflix, I love watching documentaries there, right? So whenever I'm usually on Netflix, I am watching a documentary. That's absolutely for sure. I really don't watch movies, or I really don't watch a lot of TV shows, let's just say. Now there's multiple plots, right? If you're watching a documentary, something may be related to environmental impact, something just be explaining how the human psychology works, or anything as such. So everything has a plot, right? If you're thinking about movie genres, you can find so many plots that he or she intended to do something to this person, or they try to hack that computer. They did something, right? You'll understand the plot of the movie. Every movie has a plot that anyone can discern, and that is also used for recommendation. That's what I wanted to say here, right? And then take a look at the third thing. It's languages. Of course, languages will be a feature, right? A lot of the movies are available in a lot of different languages, but what is its original language? Was it dubbed later? You can find a ton of details about that as well, right? It doesn't mean that the top movie list always has to contain Hollywood movies itself, right? Not fair. There has been fantastic movies everywhere across the globe. In fact, I read a small quote on Instagram a couple of years ago. It just said that your experience for movies will actually open up a lot more if you just get across this barrier that's called as the language barrier, right? So if you just start understanding of how well a movie is made, even though you don't understand the language, of course we'll have subtitles and you can watch it. A lot of Korean movies, K-dramas, and all those music genres from Korea, South Korea, of course, again, if you see that they're super popular everywhere across the world, considering that people might not know how to speak Korean, right? Again, why do you think that is? Similarly, similar logic here as well. Take a look at word count next. Word count is super, super, super important, and it is a very important feature. In our case, I'll explain why. First of all, word count really matters a lot, right? In a country's election and in a movie's review, equally. When I say a movie's review, it is super important for you to understand that if there's a movie that's being made, that's released to the public, there's a good chance a lot of people are going to watch it. Some of them or a lot of them are going to give their reviews. So how many people actually put down their reviews, put down their ratings? Because, some people may have absolutely loved the movie and the others might have absolutely hated it, right? So it'll give you a balanced score. If 10 people have given a score of 1 and if 10 people have given a score of 10, it'll give you an average and say 5 out of 10, because that's how weighted averages work. That's how we're going to be using weighted averages as well, right? But at this moment of time, what you really need to understand is that it's an important feature. We are going to be using it, and especially for our case, it's going to matter a lot. Right? Okay. Now, I know that all of you all are very, very curious to do this on your own. That's the reason I want to talk to you a little bit about these files that we have when you take a look at the entire movie lens dataset. Right now, we're not going to use all of these things. We might use some of these, or we might not at this moment of time. But what I want to do is I want to make sure that I'll give you a little bit of a hint of what's present in the dataset files, right? First of all, take a look at movies_metadata.csv. This contains all the information with respect to features like what genre it is. So it might be a sci-fi movie. So it might be, something else. It can be documentaries. It can be comedy movies. It can be stand-up. So there's a lot of genres and a lot of languages. You get the point here, right? So all those details are present in this particular data set. Then we have links.csv. Links.csv basically consists of all of the IMDb IDs, right? An identification tag or a number that's given to all the movies that's present in the movie lens dataset. When we are practically trying to solve this problem, you will actually take a look at the IMDb ID of that movie as well, right? Perfect. The next thing we have is credits.csv. Credits.csv talks about all the people, that made the movie possible, be it the actors or be it everyone else apart, from the actors as well, right? Now, you are actually seeing, a tiny movie, let's just say, right? You're actually using this to learn. This is a tutorial. Now, me as a subject matter expert, in the areas of data science or anything like that, it's just not my effort that's gone into making this particular content for all of you all, right? We have editors in the back end. We have an entire team, right? So we have a lot of people. When I say a lot, it's in capital letters. A lot of people who come together to make this possible, right? So kudos to each and every one of them in our own ecosystem, and similarly in the movies as well. Recommendation systems use this to recommend people to you. Maybe you have a favorite director, maybe you have a favorite producer, maybe you just want to watch movies from that particular person who is the director of photography, the DOP of that movie, right? Something like that. So of course, that's also possible. And with the data set and information we have, you can build a recommendation system using that too. Why not, right? Take a look at the last file. The last file just says keywords.csv. Keywords.csv is a very simple data set. All it consists of is the movie plot keywords for the movies. So as I just told you, it can be a movie which has a plot, maybe which is not very serious, which has a very nice message, or if it's something which has a lot of action, thriller, all these things, right? So I'm not talking about the genres, I'm talking about the effect the genres have on the movies itself. That is what makes a plot, right? So all of those details are present in this as well. Now what we want to do is let's just take a look at the data set in a manner that we are going to just understand what it is exactly that we're using, what is exactly present, how are we going to achieve this. First of all, our entire data set consists of 26 million ratings, right? So basically, it doesn't mean that there are 26 million movies where one person sat and did it, or 26 million movies where everyone just voted once. No, a total of 26 million ratings, right? And then 26 million ratings come from 270,000 users, as you can see. So a user will go review or rate more than one or two movies for sure, right? It's pretty common for you to figure that out by now. And how many movies are there in discussion right now? There's 26 million ratings by 270,000 people for 45,000 movies, right? Now take a screenshot of it or write this down, because this is our entire data set broken down literally for 3 metrics for you guys to easily understand, right? 45,000 movies, which has a total of 26 million ratings given by 270,000 people. This is our entire data set that we'll be using, right? But then when you take a look at IMDb's rating, right, any movie, let's just say Titanic, right? I absolutely love Titanic. Now it has a rating, let's just say 7, 8, 9 or anything like that. Now when you have a rating, a number, can you use it as a metric to create a recommendation system? The first answer in your head right now is absolutely why not. A movie of 9 is definitely a lot better than, maybe a movie of 7 or 6. I might agree with you, but to teach your computer how to do this, it's very different. Take a look at the example I have on your screen right now. Let's just say I have 2 movies for you, movie 1 and movie 2. These are 2 very different movies, right? So movie 1 has an average rating of 9 out of 10 on IMDb, and there are 25 people who have voted on this. Movie number 2, on the other hand, has an average rating of 8.5. It's voted at 8.5. That's the number that matters to us, right? 8.5. By how many voters? There's 25,000 voters who cumulatively, when you take an average, brings it to 8.5. Of course, with movie 1, you just take the average of 25 voters and that brings it to 9. Now, just looking at it, movie 1 and movie 2, you know that both of them might be really good movies, or that the first movie might be a bad movie, but you can never be sure, right? Think about it. Just of the fact that it has less voters does not mean that the movie is not good, right? Not possible. It just means that movie 1 might have just released and movie 2 can be 10 years old, 1 year old, or whatever it is. That's why it has seen more people who have given their reviews into it, right? So it is very common to think that the metric, it'll actually favor movies with the lesser votes, right? It is a data point, or it's a skew in the data that we are not looking for. We want accuracy. But if there is a metric which might favor just movies with lesser votes, thinking that, hey, right now, A movie which has a 9 out of 10 rating and 25 voters is like a million times better than a movie which has 8.5 rating given by 25,000 people. Does that make sense to you? The first thought that you might say is, no, right? Yes, of course, if it doesn't make sense to you, now think about teaching a computer how to do it, right? So all the features, all the external factors, you can have a ton of different things to actually solve this problem. Coming to the answer of the question, can you use rating as a metric? Yes, you can, but there are certain caveats and there are certain workarounds for these caveats as well, right? We just saw the caveat. If there is a brand new movie, less number of votes and a higher average, what it'll do, the recommendation system is it'll just recommend it to the top of the screen and say, hey, you know what, even though it has only 3 votes or even 2 votes with a 10 out of 10, it'll just tell it as, hey, this is a top movie. No, that's not a top movie if it's rated just by 2 people. Maybe they absolutely loved it, but still, the average rating is somewhere around, 1,000 people, a lakh, a million, 500,000 people, something around that, right? You need a lot of data. You need actual people who have given their ratings to ensure that you have something to track. That is the reason why this system has one tiny disadvantage, but don't worry, that disadvantage will not hurt us one way. To go on to solve this disadvantage that I just mentioned to you, you'll actually be using many features to ensure that rating is not the only metric. The second thing you're going to do is you're going to try to fix that mathematically, right? I'm going to show you how a fantastic concept we're going to be checking out. And it's not just that you're going to have external factors, you're going to have other factors which will pitch in to make sure that, there is no favoritism for movies with like lesser votes. Mathematically, that is what your computer wants to do. It'll just pull it right up to the top and say, hey, this movie has 2 votes, it has a 10 out of 10 IMDb rating, this is the top movie in the entire world. It wants to do it, but we are trying to make sure that it cannot do it, right? That's the point here. So what do? First of all, what we do is we use this fantastic concept in mathematics called as weighted averages. With weighted averages, what we do is we take into account not just the rating, but the number of voters also. So each of the voter will have his or her own rating, right? So you can take the entire average, club it in. There is a very good difference between an average and a weighted average, right? Now, to tell you what a weighted average is, a weighted average consists of the contribution from each of the individual user that had the large impact on that one particular number, right? If there are 10,000 people giving their own ratings, at the end, what do we see? We can of course see each of the 10,000 individual ratings, but IMDb shows us one number, right? One average. It'll tell you weighted average. In fact, if you go to IMDb's website and take a look at it, I'll be discussing about the formula that we're going to be using, how we're going to be using it as well. But at this moment of time, you should be very clear that this entire thing works by we solving the problem of removing favoritism, and that can be done by applying mathematics in a fantastic way, right? So what will happen if we do this is that a movie which will have a lot of voters will have a decent enough higher score than compared to a movie which has like the exact same rating, but it has lesser votes, right? Now, if you just couldn't follow along what I said, take a second, pause the video, read the second line, read the second point on the that's written on your screen, and you are going to understand, right? Because if you're just talking about score, rating, voters, it might confuse you, right? So take a second to read that. You definitely will understand that, right? What we're trying to do is movies with lots of votes will have a higher score than having a movie which has maybe exact rating, but it has less votes, right? Exactly what we saw here previously. But then just think about if the ratings were the same. 25 people rated it at 9, 25,000 people rated it also at 9, right? Now this is the problem that we're solving using weighted average, and of course I just gave you the answer to a question I was about to ask as well. Anyway, coming to the formula that we're going to use, how are we going to find the average rating of a movie, right? This is how we're going to do it. There is a simple mathematical formula. I suggest you guys write this down or take a screenshot of the same as well. Right? So the formula is voters divided by voters plus minimum votes into average rating. Let me explain this first part for you all. So what we're trying to do here is, first of all, you have the average rating, right? The entire rating that you will calculate from all the people that's present there. Voters are, of course, the number of people who put the vote. It is simple. I think that rating and voters should be understandable by you right now. When I say minimum votes, what is this minimum votes that we're talking about? Minimum votes is a fantastic concept where we are actually trying to set a cutoff. We are using that as a cutoff to say, hey, I want a movie in the top list if it has, let's just say, a minimum of these many reviews, or that I'm going to consider one tiny percentile of an entire data set and say, hey, if it sort of has all of these details and if it has these many minimum votes on an average compared to the entire data set, I want that to be considered for my top list as well. That way, if regardless of it being a new movie, an old movie, less votes, more votes, you just have the average of everything and one really, really accurate mathematical score, which is basically the IMDb rating in itself, right? So our system is going to do something similar to this. And in fact, at the end of our demo that we're just about to discuss, we will have two columns where one, it'll show us IMDb's rating, and in the next column, it's going to show the rating that our recommendation system gave us for us. That is the part which is super exciting, and you will see that a simple recommendation system can actually stand up to the IMDb's list, and it can do a damn good job at it, right? So I hope all of you all are excited to analyze the result. Now, this is basically me repeating what I just told you guys. IMDb will rate a movie at 9.1. Let's just say this is what 100 million people have rated 3 movies at. Now, what our recommendation system is going to do is it's going to use a lot of that. It's going to use other features. It's going to calculate a weighted average. It's going to tell us, hey, IMDb thinks it's 9.1, but from our own mathematical calculations and from our own implementation with our movie recommendation systems, it'll say, I think this movie is worth 9.075. That's the score out of 10, right? If IMDb says 9.1, and if our movie recommendation system says 9.075, or if it says 8.9 and ours says 8.85, well, it's pretty close, right? When you think about it, that is the fun thing about our movie recommendation system. It's super accurate, it works fantastically well, and it does a damn good job. So what are we waiting for? Let's head to Python and let's check all of this out practically, right? Perfect. Now, what I'm going to do is I am going to open up Google Colab, guys. Google Colab is basically a Jupyter notebook that's hosted on the Google Cloud platform. To get to Colab, all I do is I just type in Colab, and the first result, of course, since it's Google's own search engine, they'll give us this particular result, right? So Google Colab is basically a Jupyter notebook that's hosted on the Google Cloud platform. You might have used PyCharm, you might have used any other Jupyter notebook or something similar to this. Well, basically, we are trying to have the same effect of having a very simple Jupyter notebook where we can write our Python code, hit enter, and it works. That is it. I really don't have to install anything. I don't have to configure anything. I don't have to break my head about why things are not working. Is there anything wrong with my operating system? Is Python installation wrong, or have I missed something? Nothing, right? So this is a sample page. Let's just take a moment. Let me sign in, and we can resume this as soon as I sign into my Google account, right? Alright guys, so I just quickly logged into Google Colab. So basically I am using my Google account. If you just have a Gmail account, or you just have a simple plain Google account, you can actually create it. You can use Colab for free, right? Now I can write code anywhere I want. I can do it in my phone, I can do it on my smart TV, I can do it on a 20-year-old laptop if I want, or I can do it wherever I want, where I have access to a good browser like Google Chrome or Firefox or something like that, right? So if I'm sitting in a cafe eating my breakfast, I can do it. If I'm sitting at Starbucks sipping my favorite cup of latte, I can sit and still write Python code. That's the reason I've been using this almost all of my entire programming career, right? So anyway, coming back to what we're about to discuss. So what we're trying to do here is, again, as I told you, build our own movie recommendation system in Python, right? The first thing that I really need to do is I have to connect to the runtime, right? So I have to connect my Google Colab notebook to a Google Cloud Platform's server. So it uses its own set of hardware, right? Everything from RAM, CPU, graphical processing unit, as in graphic cards, GPUs. It uses everything that's already present at one of Google's data centers anywhere around the world right now. And you can look at that, right? Look at this. One bar shows you that right now we are using somewhere around 0.7 GB of RAM, and we're using somewhere around 38 gigs of space, out of which this is basically the entire thing that's given to you for free. There's something called Colab Pro as well. Let's not get into that right now. Okay, let me zoom in a little so that all of you all can see this correctly, right? Okay, I think this should be fine. Perfect. So Ladies and gentlemen, welcome to the demo. The first step of whenever you're trying to solve any sort of problems is basically importing all the libraries that you're going to require. And right now, all the libraries that we're going to require is one library in Python, the most powerful library in my opinion, which is the pandas library, right? So pandas library gives us access to two fantastic data structures or two ways of how we can save the data. One is called as series, the other one is called as data frames. Now, most of these places we're going to be using data frames and without which this entire aspect of how we can use the data, give it, input it into Python and make it sort of understand what it is and to give us a working result would have been extremely difficult. So I absolutely love the libraries such as NumPy, Pandas, of course, scikit-learn for machine learning, and if you're thinking about it, Seaborn and Matplotlib for visualization. I just named the top 10 libraries for Python, but these are super powerful and there are multiple reasons of why they're popular, right? Okay. Anyway, let me just click on the play button, which I did. And right now, Pandas library is imported. So Python is ready. Pandas is ready. I didn't have to install anything. What is step number 2? Step number 2 is basically us importing the dataset. You remember when I walked you through the dataset files, we spoke about this particular file called movies_metadata.csv, which consists of all the details, all the metadata. So what we're going to do is we're going to be using Pandas read_csv function to actually load it into our working environment. Now, you might have observed this particular feature here, which says low_memory equal to false. So what we are basically trying to tell Pandas is, hey, you really do not have to work about efficiency. You really do not have to work about using the lowest memory to store or work with all of these data sets. It's okay. So we are really just taking efficiency, throwing it out of the window because we do not, we're not caring so much that this is a live product which needs to give you live results, right? It's fine. Use a bit more of data. It wouldn't hurt in this particular case. So as soon as I run this, if you're wondering where all the data sets is, look at this. It just says my drive, right? So basically what Google Colab has done, it has connected my Google Drive here. So everything from my Google Drive, if I just go to drive, my drive, and I have a folder called as movie rec there. Movie rec is basically the movie recommendation. Let me just open it. I have a lot of files on my Google Drive, so it might take some time. Let's just see if it does it. Okay, right now I think there's a small bug where it might not want to open. Okay, anyway, so the point here is very simple, right? So all I just wanted to show you was open up Google Drive and show you the particular dataset file's existence, which again, if I hit play and it works and there is no error, it means it was correct, right? Okay, cool. Anyway, let's move on. The next thing that we're going to be doing is basically trying to print the first 4 rows of the dataset to understand what it is that we are going to discuss, right? For this, I really have to zoom out, guys, or else you will not be able to see anything. Look, the first thing that we're going to take a look at is, of course, whenever you're thinking about movies, there is usually a lot of age restrictions, right? The first column always talks about the age restriction, of course. And the next thing is it talks about the identity, the ID of the movie. You remember where I told you about the IMDb ID attached to every single movie present on the IMDb dataset? There is an ID there. What is the budget of the movie? How many crores of millions of dollars was used? What is the homepage of that particular movie? What genre it is? For example, it just says Toy Story collection. I know that Toy Story is an animated movie here, right? Done. And then when you're thinking about other movies, for example, think about Jumanji. Jumanji is an adventurous movie, right? So the genre is adventure. It has the ID. This is the IMDb ID I was just talking about, and it'll give you the original language as well. For example, all of these movies right now, it says EN. EN is basically English, right? And then you can take a look at the overview of the movie as well. Hang on, let me just scroll a little to the right so that you guys can see this, right? You have overview, right? Overview is basically like 2 sentences of telling you what the movie is without revealing what happens at the end or without giving you any spoilers, right? That is overview. And then you have popularity, and then you have the actual poster of the movie. Who is the production company? We know all of these names: 20th Century Fox, Warner Brothers, TriStar, Pixar Animation Studios, and all of these, right? You have details such as which country produced it, what is the actual release date of that particular movie, how much revenue it made, what is the runtime in weeks, spoken language in the movie, what is the status of the movie. Now you can have a movie on IMDb which is not yet released as well, right? They can have the plain page up. So we have a status tab which says this movie is either released, not released, or something like that. And then you have something called as a tagline. You have the title of the movie. It'll tell you if you have a video, maybe of a trailer or something like that. But what we are very much interested in is these last 2 columns, the average vote which people have given to that particular movie and how many people have given a vote, right? So for example, example, right now, if we take a look at Toy Story, there's an average rating of 7.7 and 5,415 people have actually given this rating, right? So looking at the data set, it's not really complex. It's a very simple data set. And if we take a look at it, it's not even a lot of code that we are about to discuss, right? As in, when we go across the next step, you will be fascinated about how simple this is, yet how super powerful this is, right? Now, how many movies do we have? If you remember, I told you that on an average, we have somewhere around the data of 45,000 movies, right? As you can see, we have somewhere around 466 entries. So let's just say we have 45,000 movies on an average, right? These are all the columns that I just told you about: budget, genre, ID, IMDb ID, overview, popularity, title, video, revenue, runtime, release date, average count, all of these things, right? Perfect. So we have 45,000 movies. We looked at the data set. We know what all the data sets do. We know the most important parts of the data set as well, the average votes and the number of voters as well, right? We need that to perform weighted average. Can you perform a weighted average without knowing the number of people? The answer to that should be a very quick and a straightforward no, because a weighted average talks all about how an individual contributes to the entire result. If you take away the entire individual out of it, there is nothing that can make sense there, right? So you have to have the rating and the person who has rated that as well to consider for it, right? Perfect. Now, what's the next thing that we're going to do is, we have 45,000 movies, right? Let's take an average and understand what is the entire average IMDb rating of all these movies that we have. The entire rating is 5.61, right? It'll probably consist of movies which are not liked by audience a lot, and of course movies which are loved by audiences a lot, right? So 5.61 is definitely a good rating in my opinion, considering a lot of these movies, right? The next thing that we're going to have to do is, remember when I told you about this minimum votes? This minimum votes is where we set a cutoff saying, hey, I need these many minimum votes if I have to consider this movie to put on my top list, right? So what you do is you can divide your data into quartiles, and quartile is basically a division between minimum and 25th percentile, 25th percentile to 50th percentile, 50th to 75th, 75th to the maximum value that's present, right? We have something called as interquartile range, and all of these are statistical terms that I'm just telling you. In case if you do not know about what I'm talking about in terms of quartile, at this moment of time, it is okay. You really do not have to give a lot of thought to it in terms of either breaking your data in a normalized form in terms of quartiles with an R, or as you can see here as well, right, a quantile when you're talking about quantities as well. Now, as soon as I just go on to hit play on this, it'll tell me that it's 160. Now, 160 is basically giving me a value saying, hey, if a movie has to be considered to go on that particular list, that movie really needs to have minimum of 160 votes, right? You can change this value to anything you want. I have just given a value of 0.9 here. You can give it 0.1, 0.2, 0.3. You can have any number of people as the minimum vote, right? This is where you get to customize your recommendation system. Well, once we have actually gone on to do that, the next thing we have to do is, right now, we need to filter all of the movies which have an average rating, or let's just say where 160 people have voted, right? We have 45,000 movies as of now, but this doesn't mean that all the 45,000 movies have a minimum of 160 votes each. No, right? So we're going to find all the movies where the minimum number of votes is 160, and we're going to take all of that, dump it into another data frame, and this data frame we're going to be calling it as Q underscore movies. Now we are just copying it, so we are not touching the original data set which consists of all the data. What we are trying to do right now is having our own data set of movies where the rating where each movie is rated by 160 people, right? So you can see that there's 4,555 movies in our list doing that right now. So you remember that mathematical formula that I just showed you about how you can calculate the entire weighted average on your screen, right? So that entire logic where we have one section which talks about the minimum voters, we have another section which talks about individual contribution of each of these voters to the end result, right? So when you actually go on to add these two components, it will give you an average that you saw. You can actually do it mathematically. Take a simple example, take simple values out there and try to see if you can manually find the weighted average. It's a very, very simple calculation, and I promise that you can do it as well, right? So all this function is doing, the weighted rating function is basically to take all these things that we just found out. What is the minimum number of votes that we want? What is the average vote that everyone has put in the entire data set? And we're trying to return that particular result, that particular rating for the score of the movies that we have, right? Perfect. Now we did it for one. How can we go about doing this to apply it for all the scores of all the data that we have right now? Well, we can actually calculate the score considering this exact weighted average that we just found out, and we can do this in a pretty simple manner. And you guys are taking a look at this, right? All of these are very, very simple lines of code. There is not a lot of line. In fact, let us just finish this, and we're going to look back at how simple it is. Okay. Now, right now, we have taken a look at the weighted average in consideration. We calculated the score as well. The next thing that we have to do is, as I told you, right now our recommendation system is ready, but it does not have a top 10, top 20, top 30 list. To add the term top and to give meaning to it, you have to arrange everything in the descending order, right? Best movie first. So as soon as I click on this, basically it just changed everything in the data frame where the highest rated movie go to the top, the lowest rated movie goes to the bottom. Now, I'm going to show you a fantastic feature of pandas that you might not know about. But before that, let's take a look at it. This is our result. This is the entire thing that we were hunting for with this small amount of code that we have, right? Take a look at this. It'll give you the title of the movie, the number of people that have voted there, and the voted average of it, and the score that our recommendation system gave us, right? Now, this is the most fantastic thing. The movies that are present here are absolutely amazing, right? Apart from 2 or 3 of these movies, I have literally watched all of these. Even though I'm not a movie guy, these are some of the most classics in the world. Shawshank Redemption, The Godfather. As I told you, the list does not consist of only English movies. You can see DDLJ, right? Dilwale Dulhaniya Le Jayenge. This is a very famous Bollywood movie, and this again is present in the top list as well. You have Dark Knight, Fight Club, Pulp Fiction, Schindler's List, Whiplash, guys. Forrest Gump, I was just having a conversation about this particular movie with one of my friends right now. So when you take a look at it, these are fantastic movies. These are the number of people who have voted for these particular movies, and these are the average ratings for that people have given for these movies. But if you take a look at our scores, let's just say this is the top list, right? This is the top 20 movies list ever that our model gave us, and you can see that the scores match, or they're very close almost, right? If the people say, hey, I can give you an average rating of 8.5, our scoring algorithm, or our system of finding weighted averages and having a recommendation system says, hey, I can give you a score of 8.4 using that particular vote average and using that many people who have voted. That's absolutely fantastic, right? It's super close. Take a look at this. We have another one, Godfather. It says 8.5. Our score is somewhere around 8.4. Then we have DDLJ. Of course, DDLJ has a slight deviation to it, but then the scores are not, what we are not trying to compare is these two items directly. This is a score that is, again, what you have to consider about is just taking a look. See, if DDLJ was 9.1, it had to be at the number 1 spot in our list right now, right? Because this is the average vote given by the people. But it's not. Why? Think about vote count, think about the actual vote, think about the movie cast, think about all the million other features that actually went into this particular thing, where all we tried to do was attach a score element to each and every movie, and the highest score was arranged from the descending order, right? So this is a fantastic result in my opinion, guys. Now let me actually zoom out. Let me actually clear all the outputs. Let me just show you, again, I zoomed out, guys. So if it's a little tiny right now, do not mind. I just want to count the number of lines of code, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Let's just say 25 lines, right? You built an entire movie recommendation system which works absolutely well on a very well-renowned, data set using fantastic approaches, and also considering the fact that having metrics might skew your data up, and finding a fix for that, fixing it, and having a working result at the end was absolutely fantastic, right? So guys, as you saw, 25 lines of code, less than 25 lines of code, we actually achieved it, right? Oh, in fact, we actually forgot one tiny thing to show you here. Let me just actually just run the last thing again, right? So as soon as I ran the last movie list again, you can see the movie list, right? Of course, this is supposed to say print the top 20 movies. But then you can get to see how simple probably it is to work with Google Colab, right? I just changed that. Look, simple. Right now, anyway, you can see this score right now. This score is like super confusing as soon as I look at it. It has so many decimal places. I just want 2 decimal places. So I'm going to set an option. Basically, Panda has a function called set underscore option where you can customize what it is that you want pandas to show. And if I actually run this and take a look at this last column, it says 8.445869. Let me run this again. What it's going to do now, it's going to cut everything out and it's going to basically give me a score rounded to the second decimal place, right? This looks a lot cleaner for our data set. And this, again, is just formatting options, and you can convert this into a chart. You can create a beautiful looking dashboard out of this. You can do a ton from here. But then to get to here was the entire goal of our presentation, right? So guys, this is the fantastic demo that we had a look at. Alright guys, so that brings us to the end of this particular session, right? We had such a fun session. We took a look at everything from the introduction of recommendation systems, how they work, why they were put into place first of all, how fantastically they work, and we also understood how Amazon uses it, Facebook uses it, Netflix uses it, of course, everyone else as well, right? Once we took a look at that, we also had to concentrate a little bit about the theory aspect of how we are trying to attack the problem and solve it. So we discussed the problem statement, we discussed the steps to solve it, we discussed a lot of details about the data set. We even found a potential problem which might hinder the result. So we actually solved that particular problem in a way where it wouldn't hurt the result. And eventually we solved it. We understood how everything works theoretically. And eventually we moved to Python. And in less than 20-25 lines of code, we did all of it practically. And right now we have a working mobile recommendation system, right? How fantastic is that? So ladies and gentlemen, with this, we have come to the end of this session. I hope I was clear with every point on the agenda that we had to discuss on this particular session. If you have any comments, any suggestion, or if you want to tell us about your own recommendation systems that you built using this tutorial, guys, head to the comment section and put down your messages there. Let's take the conversation up and continue there, right? On that note, guys, thank you so much for watching. My name is Anirudh Rao. I'll see you on the next one.
I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains, absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.